Imagine a technology so advanced that it completely shatters the laws of physics as we know them. A spacecraft capable of traveling at 1 light-year per second. Light itself, the fastest thing in the universe, needs an entire year to cross that distance. But with this impossible machine, you would cover it every single second. At that speed, the universe stops being distant. Stars are no longer unreachable. Galaxies are no longer abstract ideas. Space itself becomes a road. Our journey begins here, on Earth, a small blue world orbiting an ordinary star, tucked away in an unremarkable corner of the Milky Way. From this quiet starting point, we will leave everything familiar behind. In moments, planets will vanish. In seconds, stars will surround us. And in time, measured not by clocks but by scale, we will move from our cosmic neighborhood to the very edge of everything humanity has ever observed. This is not a journey bound by reality. It is a thought experiment, one that allows us to grasp the true size of the universe. In Part 1, we leave home. We race past the solar system, cross interstellar space, and explore nearby stars, alien worlds, and colossal suns that live fast and die violently. In Part 2, we go further. Beyond individual stars, beyond galaxies, beyond clusters of galaxies, toward the largest structures ever discovered, and finally, to the edge of the observable universe itself. So take a breath, because once we begin, there is no slowing down. The journey begins on Earth, a small, fragile world suspended in darkness, orbiting an ordinary yellow star. From the surface, the universe feels distant, stars reduced to pinpoints of light. But the moment our spacecraft ignites, that illusion disappears. In the first second, we surge past the inner planets. Mercury and Venus vanish without ceremony. Earth becomes a pale dot behind us. Mars flashes by, followed by the gas giant Jupiter, its endless storms frozen into a shrinking sphere of color. Another second passes. Saturn's rings collapse into a thin line. Uranus and Neptune fade into the black. We tear through the Kuiper Belt, a vast halo of frozen debris, ancient remnants left behind from the birth of the solar system. Almost instantly, we reach the heliopause, the invisible boundary where the sun's solar wind finally surrenders to interstellar space. Here, the influence of our star ends. Beyond this point, there is no shelter, no warmth, only the deep, silent ocean between stars. After 4 seconds, a new sun rises ahead of us, Alpha Centauri. The closest star system to Earth, located 4.37 light-years away, appears not as one star, but 3. Alpha Centauri A and B orbit each other in a delicate gravitational dance, while the faint red dwarf Proxima Centauri lingers nearby. Around Proxima, at least one planet circles within the habitable zone, a world that could, in theory, support liquid water. This system has become humanity's first true interstellar destination, a reminder that even in the cosmic wilderness, neighbors exist. At 8 seconds, we arrive at Sirius, the brightest star in Earth's night sky. What looks like a single beacon from afar is actually a binary system. Sirius A burns hot and white, while Sirius B, its companion, is a white dwarf, an object so dense that a teaspoon of its matter would outweigh a mountain. These stars mark the transition from familiarity to strangeness. At 40 seconds, we encounter 55 Cancri E, an alien world beyond anything in our solar system. It orbits so close to its star that its surface temperatures exceed 1400 degrees Celsius. Beneath its crust, immense pressures may compress carbon into vast layers of diamond. A planet shaped by extremes where geology itself behaves differently. As the seconds stretch into minutes, stars grow larger, more violent. At 14 minutes, we pass near Rigel, a blue supergiant burning over 100,000 times brighter than our Sun. Stars like this live fast and die young. Their short lives end in catastrophic supernovae, explosions powerful enough to forge the heavy elements that later become planets and life. We are no longer just traveling through space. We are traveling through the life cycles of stars, and this is only the beginning. In Part 1, we left home. We crossed the solar system, touched neighboring stars, and witnessed worlds of fire and suns that burn their lives away in brilliant violence. But individual stars, no matter how massive, are only the beginning. Now we move outward. As minutes become hours, the stars around us begin to blur together. Their distances stretch beyond intuition. What once felt like a crowded neighborhood reveals itself as a vast, mostly empty ocean. Then, slowly, structure emerges. After 2 hours, towering shapes rise from the darkness, the pillars of creation within the Eagle Nebula. These colossal columns of gas and dust span several light years, sheltering newborn stars within their shadows. Radiation from nearby massive stars is already tearing them apart. Creation and destruction occur side by side, sculpting the future of the galaxy. At 5 hours, we pass near VY Canis Majoris, a red hypergiant nearing the end of its life. If placed at the center of our solar system, it would engulf Jupiter. It sheds enormous amounts of mass, forming glowing shells that drift away into space, a slow-motion prelude to a coming explosion. Within 1 day, we reach the edge of the Milky Way. From this vantage point, our galaxy reveals itself as a vast spiral of stars, dust, and dark matter, home to hundreds of billions of suns, yet only one among countless others. After 29 days, another giant fills our view, the Andromeda Galaxy. Bound to the Milky Way by gravity, it is rushing toward us. In 4 billion years, the two will collide, merging into a single, immense galaxy. Galactic time moves slowly, but its outcomes are inevitable. At 115 days, we leave the local group, a small collection of galaxies drifting together through space. Beyond it lies a realm where galaxies gather into enormous clusters. After 3 years, we cross the Virgo supercluster, containing thousands of galaxies arranged along invisible filaments. And by 16 years, we exit Laniakea, the vast gravitational basin that includes our own galaxy and everything near it. A century into the journey, we approach TON 618. This is not merely a black hole, it is a cosmic titan. With a mass of 66 billion suns, it shines as a quasar, powered by matter falling toward a point where space and time lose meaning. After 320 years, we pass the Great Wall, one of the largest known structures in the universe, so immense it spans a significant fraction of the observable cosmos itself. Finally, after 1,000 years, we reach the edge. Not a wall, not an end, but a horizon. This boundary marks the limit of time, not space, the farthest distance light has been able to travel since the universe began 13.8 billion years ago. Beyond it, the universe may continue endlessly, but its light has not yet reached us. Standing here, at the edge of everything humanity has ever seen, one truth becomes clear. The universe is unimaginably vast, and yet the desire to explore it is even greater. As we leave familiar stars behind, something extraordinary becomes clear. Planets are everywhere. For most of human history, we believed worlds like Earth might be rare, perhaps unique. But as our journey continues, star after star reveals its own system of planets, each shaped by forces far more extreme than anything in our solar system. At 40 seconds into our flight, we encounter one of the most infamous of these worlds, 55 Cancri e. This planet orbits its star so closely that a year lasts less than 18 hours. Its surface temperature exceeds 1,400 degrees Celsius, hot enough to melt rock. Lava oceans may glow across its surface, while violent volcanic eruptions reshape the planet continuously. Deep beneath its crust, immense pressure may compress carbon into vast crystalline layers. Not a poetic metaphor, but literal diamond formed on a planetary scale. This is not a failed Earth. It is a reminder that planets do not follow a single blueprint. Minutes later, we arrive at Kepler 22b, one of the first planets discovered in what astronomers call the habitable zone, the narrow region around a star where liquid water could exist. Yet even here, certainty vanishes. Kepler 22b is larger than Earth. It may be a super-Earth with continents and oceans, or a global water world with no land at all. Its atmosphere could be thick with clouds, hiding its surface entirely. From afar, it looks promising. Up close, it remains a mystery. And it is not alone. Some exoplanets orbit two stars, rising and setting beneath twin suns. Others follow wildly elongated paths, swinging from freezing darkness to blistering heat. There are worlds where it rains molten iron, worlds with winds faster than sound, worlds torn apart by tidal forces stretched into glowing ribbons of gas. These planets challenge every assumption we once held about habitability. Life, if it exists elsewhere, may not resemble anything we know. As our speed carries us deeper into the galaxy, the scale becomes overwhelming. For every star we pass, planets follow. Billions upon billions of worlds scattered across the Milky Way alone. Statistically, Earth cannot be special because it is rare. It is special because we are here. Exoplanets are not destinations for us, not yet. They are mirrors. Each one reflects a different outcome of physics, chemistry, and time. Together, they reveal a universe far more creative than we ever imagined. And as strange as these worlds may be, they are still shaped by stars. To understand planets, we must understand the lives and deaths of the suns that give them birth. Every planet, no matter how strange, lives in the shadow of a star. Stars are not eternal. They are born, they burn, and they die. and among them exist giants so vast and powerful that they shape entire regions of the galaxy. As we move deeper into space, ordinary stars like our Sun begin to feel small. At 14 minutes, an overwhelming blue light fills our view. We are approaching Rigel, a blue supergiant located hundreds of light years from Earth. Rigel burns more than 100,000 times brighter than the Sun, consuming its nuclear fuel at a terrifying rate. Its surface temperature exceeds 11,000 degrees Celsius, flooding space with intense ultraviolet radiation. Stars like Rigel are cosmic engines. They live fast, shine violently, and die young. But even Rigel is not the largest. Hours later, we encounter VY Canis Majoris, a red hypergiant nearing the end of its life. If placed at the center of our solar system, its outer layers would extend beyond the orbit of Jupiter. The star is unstable, bloated, and shedding vast amounts of material into space. Gigantic arcs and clouds of glowing gas surround it, matter that will one day become part of new stars and planets. These giants exist in a delicate balance. Gravity pulls inward, nuclear fusion pushes outward. When that balance breaks, the consequences are catastrophic. Massive stars end their lives in supernova explosions, events so powerful they can briefly outshine entire galaxies. In those final moments, temperatures and pressures become extreme enough to forge the universe's heaviest elements: iron, gold, uranium. Without these explosions, rocky planets could not exist. Neither could life. In death, stars become creators. Some collapse into neutron stars, objects so dense that atoms themselves are crushed. Others form black holes, warping space and time around them. These remnants are not cosmic failures. They are the foundations upon which future systems are built. As we pass through regions shaped by ancient supernovae, it becomes clear that the universe is not static. It is recycling itself on unimaginable scales. Stars are born from clouds of gas, live brilliant lives, die in fire, and seed the galaxy with the materials for the next generation. Every atom in your body was forged inside a star. And as we continue outward, we are no longer just observers. We are witnesses to the engine that makes the universe possible. We began this journey on a small blue planet orbiting an ordinary star. In seconds, we left the solar system behind. In minutes, we crossed the space between stars. And in moments measured only by imagination, we witnessed alien worlds, brilliant suns, and stellar giants powerful enough to reshape entire regions of the galaxy. We have seen planets made of fire, and worlds that may hide endless oceans. We have passed stars that burn 100,000 times brighter than our Sun, stars that live fast, die young, and seed the universe with the elements of life. These are not distant abstractions. They are the reason we exist. Every atom that makes you human was forged in the heart of a star like the ones we have just passed. Their violent deaths did not end stories. They began them. Yet, as vast as this journey has been, we have only explored a tiny fraction of the cosmos. We have not yet left our galaxy. We have not yet seen galaxies collide, or traced the invisible structures that bind the universe together. We have not yet reached the great darkness between clusters, or the horizon beyond which light itself has never arrived. In the next chapter, we will go further, beyond individual stars, beyond the Milky Way, beyond anything that feels familiar. Part 1 was about leaving home. Part 2 is about discovering how small that home truly is, and how vast the universe really becomes.